I'm Kota Asaka from NTT, so very nice to meet you guys. So I would like to introduce our activities in SEBA development and what we have done so far and what we are going to do. Okay, so let me briefly give you the background of our motivation for the disaggregation and access. So firstly, I need to touch with our broadband strategy in NTT. Actually, NTT had updated its broadband strategy to B2B2C, which means business to business, business to business to consumers, in addition to conventional B2C. The B2C is our conventional traditional business model, providing the broadband service over FTTH system directly to our consumers, customers. So the B2B2C is we are partnering. We have a partner with the service providers as a wholesale service of the fiber to the home system, and they can provide their own service. In addition, they can provide the FTTH service in addition to the partners' their own service without having their heavy infrastructure. So this is a benefit for the service provider in terms of the creation of the new value to their own consumers. Okay, so let's take a look at this chart. So this chart shows how the new business model has been effective so far in NTT. A number of subscribers in NTT reached more than 20 million, as you can see. And the number of subscribers over FTTH wholesale service are rapidly increasing. And actually, it overtakes the conventional fiber to the home users. So it means more than 10 million subscribers. The business partners are a lot of business partners, mobile network operators, mobile virtual network operators, ISPs and local carrier TV operators, and infrastructure providers, and retailers, and so on. So it looks so far so successful. But however, we need to think about how to quickly and flexibly address the new requirement from these business partners so that they can keep providing the new value to their own customers. Okay, another motivation is coming from the workforce issue. This chart shows the workforce at the telco facilities in Japan as a function of age of the workers. Blue bars shows that a workforce in 2015 was 90,000 persons. However, it is expected that it will be decreased to 70,000 persons in 2025, as shown in the yellow bars. So this drastic decrease of 20% is caused by the decrease in the young segments due to the lower birth rate in Japan. Actually, it is around 1.4. So we need a low maintenance network, low maintenance operation and management in our network so that we can keep our huge network assets with a much fewer number of the workforce. Okay, so let me summarize our perspective. So to meet the emerging requirements by the middle-B partners, we need flexibility, agility, and ecosystem for future access system, as well as small start capability, because we had already large deployment with the legacy OLT and ONUS. And as for the workforce issue, we need low maintenance network. These possible requirements could be achieved by the disaggregation as well as SDN and NFV. So this is why we believe those technologies are promising candidates to solve these issues. Okay, here is, let me describe the derived requirements. The first one is flexibility, so which means flexible for displacement or update of functions to meet each requirement. Second one is agility, early time to market with small start manner. And the ecosystem, of course, it's the use of the open source software and white box hardware, including a modular type. And finally, low maintenance network, which is achieved with automation and or stable operation and more. Okay, so let me introduce our approach to meet those requirements. This figure shows a schematic image of our approach. Left-hand side is a well-known pizza box type OLT with the softwares, and which is suitable for the scene, whereas a large scale which requires a large scalability and a high line rate, such as large scale fiber to the home system or mobile service or large scale factory. On the other hand, left-hand side is a modular type, small modular type OLT, which could be applicable to their rural area fiber to the home or the small scale factory and campus network. So it is very small, so which is very good for the tight or limited space to install this OLT or ONU systems. So we assume a very diverse range of the application fields, never limited to the conventional large-scale fiber to the home system. In this case, we need customization of the functions because the requirements is different by the application. Therefore, we need to customize. Therefore, we believe the software components are promising candidates because we can easily, quickly customize the function as a component. In this case, in this example, DBA function is softwareized. DBA stands for the dynamic bandwidth allocation, and we also specify the API between the hardware and the software, DBA software component for the replacement. For instance, if we are going to adopt the PON system to mobile phone control system, we replace the DBA function from the conventional FTTH type to the low latency type DBA to meet the stringent requirement of the latency in 5G and beyond mobile service system. And other applications, we will develop the other type of the DBA if necessary, and to meet the requirement of each application. Furthermore, whatever the hardware type is, we will use the common software components as shown here as much as possible to establish the ecosystem in this industry. Okay, so you may notice the most of our requirements is covered by our approach, flexibility, agility, ecosystem, and small start capability. So the remaining requirement is low maintenance, which is still under study, but it will be slightly mentioned in later my presentation. Okay, let me introduce our use case of the Mini-PON. So Mini-PON is composed of the modular type OLT and the compute server and the controller server like ONUS or BOTA, and which is applicable to high-speed optical LAN at tight space such as factory, campus, and building. And it has a flexibility because most of the components are softwareized and very small, so it's very good to do the small starting. And also, this is a good example of the leveraging the deliverables from not only the ONF and also the Broadband forum. So last year, we specified the DBA API for the DBA swapping. So as a BBF TL 402 and 403, which I'm showing here. The detailed information will be presented at the international conference, ECOC, end of this month. Okay, here's a demo we had done last year. So you may recall we had a high reputation to show there how the small capability is important. Another use case is showing here. This is a mobile phone call by PON with cooperative DBA. In future mobile systems, dense small cells could be accommodated by a PON rather than the point-to-point architecture, which has advantage in terms of low CAPEX of the physical infrastructure. This will be achieved by replacing the DBA software from the conventional SR-DBA to the cooperative DBA, low latency type. Then TOM-PON-based mobile phone call can be realized. So this avoids rebuilding the OLT from the beginning. This means, in other words, we can use the same OLT box, not only the FTTH, but also the mobile phone call. This is very good for the expanded application field in our industry. We had demo also in this use case last year, June, at the Broadband forum meeting. Sorry for this is a tiny slide, but this is a box type OLT implemented DBA API and ONUs and connected to the antenna side, and the CU and the DU are connected to the OLT through the cooperative interface in order to receive the scheduling information of the UE from the BBU to OLT. Detail will be mentioned later. So another use case to meet the low maintenance requirement, we are thinking about the DTP, zero touch provisioning for the low maintenance. This is necessary because otherwise we cannot maintain our networks with a limited number of workforce, so it's a serious problem. But details on this use case are under development. One example is showing here. When we have a subscribe application, we need to dispatch the field engineer to the user's premises, as well as we need the operator's work and database update. But if this TP can be achieved, as soon as the user connects an ONU to the network by a DIY manner, automatic authentication will run, and line opening will be achieved as a service startup immediately. Okay, so from now on, I would like to introduce our activity in the SEBA project. So we have two main parts. The first one is SEBA reference design contribution, and the other contribution is a Broadband simulator. So, here's handsome guys, Kota, and the new guys, Takahiro, from this August, and you may know him there. Thank you for accepting those guys. Okay, so the first one is contribution to SEBA reference design. So we developed the Mini-PON as our use case, and not only the development, but also to the contributed to the SEBA reference design, which is a modular type OLT architecture, and which is included in the reference design document. So not only the box type, but also the modular type OLT are reflected as a reference design in SEBA RD. Another contribution is the Broadband simulator. Kota implemented the right-weighted responder bottom part of the orange box for improving the simulator's scalability. And thanks to the lattices, other component, gRPC and REST API server for controlling the simulator are implemented. And this improved the simulator. He evaluated the Volta scalability 1.6 and reveals its scalability issue, unfortunately. But it is a fact. But it will be solved in this performance in the later version, of course, I believe. And what happened is that, so he measured the elapsed time for each ONU ID from 1 to 64. And as an example, as ONU ID was 30, each plot indicates the timing of each process. Okay? And in total, from starting of the first ONU of authentication until end of the last ONU IP address assignment, it took 150 seconds for 64 ONUs. So this will be this was a problem, but again it will be solved. BBSim itself, now they are thinking about the redesign plan. Matteo of ONF proposed a redesign for improving the readability and the scalability, targeting the more than 1,000 ONUs. And some parts of the current simulator will be reused for implementing the new one. NTT is also supporting this activity and will keep contributing. Okay, so from now on, I'll talk about our future plan in SEBA. We have 3 plans. The first one is EPON compliant, both are. And the second one is contribution to NAM. The last one is SEBA as X4 platform plan. Okay, the first one is simple. So as you may know, current Volta is compliant with the ITUT ZPON, but not EPON. But NTT is using the IEEE EPON, so we need actually EPON compliant Volta. And also, which should provide benefit for other EPON users, service providers. So NTT will lead this project with TBIT and Furukawa soon, and the other partners should be welcome. The next one is NAM. So this is still under preliminary stage, but we are thinking about this kind of example. So NAM function for a low maintenance network. So if something fault has happened at the central office, currently it is difficult to identify the which OLT and which rack. So it's difficult currently, but if we achieve the locate information correction, we can easily find it, and it contributes to the low maintenance network. So in that sense, we require the API for location information and WANC for OLT installation. So such kind of things we are thinking. So the third one is the SEBA as xhaul platform. Current activity in SEBA are mostly dedicated to the fiber to the PON service. Of course, I know that now SEBA project is going to expand it's beyond the PON, so like FTTH and millimeter wavelengths. So I agree with that, fully agree with that. And to establish the further ecosystem in the access industry, application field of SEBA should be expanded. So that's why I'm supportive. So one of the candidates is the mobile services, we believe. Okay, let's think about the mobile optical network in 5G and beyond. So here is a macro cell in the current situation, but in 5G era, small cells will be deployed densely at area of high population density. So you can easily imagine too many optical fiber as the same number as the small cells need to be installed, right, as a point-to-point architecture. It should be very costly. But the utilization of the PON architecture to mobile optical network, that reduces the number of optical fiber and contributes the construct it cost effectively. So this is our target. But of course, we have some technical issues. The first one is bandwidth reduction. So that requires a new interface. The other one is the low latency. To achieve the low latency, to meet the low latency requirements, we need the two functions. One is cooperative DBA. The other one is the cooperative transport information to receive the UE scheduling information from the mobile system. Okay, let's take a look at one by one. So here is a high capacity requirement by CPRI transmission. CPRI is a current specification between the BBU and the RRH and optical bandwidth, optical transmission. It requires a very, very large optical bandwidth. In the 4G case, wireless transmission rate is 300 megabps, but it requires the bandwidth of 4.8 gigabps in this section. In case of 5G, the base rate is 10G, so it becomes roughly 160 gigabits. So it is not practical number. So that's why 3GPP and other organizations are discussing about the new definition, like a splitting point of the mobile front haul. 3GPP recently specifies the high layer split position. They are going to specify the lower layer split position as well. This is because there is a trade-off between the mobile front haul optical bandwidth and latency requirement. So another technical issue of PON for the low layer split mobile front haul is that it requires a low latency between CU-DU and RU, less than 250 microseconds one way. But the generic applicable latency between OLT and ONU is about 1 milliseconds due to the conventional DBA, if we use the PON system between the RRU and BBH. So this is the latency cause of the current DBA for the FTTH. So OLT schedules each ONU uplink transmission according to the request from the all ONUs and send schedule result as a grant to the ONU, this procedure. So this procedure causes high latency more than 1 millisecond. But if we achieve the cooperative DBA, it will be drastically decreased. So CU-DU controls uplink transmission of UE and has information, of course, time and the bandwidth of the uplink transmission. So if this scheduling information is given to the OLT through some kind of interface, we call this as a cooperative interface, OLT can execute the DBA calculation before uplink data comes in. So the cooperative DBA reduces the latency greatly, and the cooperative interface between DU and OLT is needed instead. Here is a prototype evaluation of the cooperative DBA between CU and DU and OLT. So the conventional DBA provides a latency of around 1 millisecond. On the other hand, using the cooperative DBA and the cooperative interface, we achieved successfully less than 50 microseconds. So quite good number. So in addition to that, we need the DBA replacement. So as I mentioned, to avoid the rebuilding the OLT from scratch, so we can use not only the fiber to the home, but also the mobile front haul. We can use the same OLT if we can implement the DBA API and the cooperative interface in the OLT box. That's why we tried to the standardization at the Broadband forum. So recently, last year, we succeeded in the specification of the this kind of API, which divides the DBA engine part and the algorithm part. So we can, this part is a software, so we can easily exchange the DBA type. And this was released as a TR402 and 403. This is too detailed, so I can skip this. Okay, so the current standardization activities related to this mobile front for application. Now, OLT side, we had already done by F7ITUT as G.989, G.HSP, as well as Broadband Forum. Now, the rest of the not standardized is a cooperative interface, or CTI recently. But with the cooperation of AT&T and Nokia, we ORAN started to this specification, and it will be finished by end of this year. Okay, so this is just a brainstorming now. What are missing parts in SEBA if this mobile front haul achieved by the SEBA? I think white box needs have the standard component interface all around the BBF, like a cooperative DBA and the cooperative transport interface as well. And another functions could be the QoS control and time synchronization functions necessary, whatever the hardware level or CDN controller level. This should be under discussion. QoS means priority controls between the mobile main signal and the scheduling signal. Time synchronization means time synchronization between the mobile system and the SEBA system. So this kind of functions are missing if we think about to use the SEBA. Okay, so another thing, white box optical access node concept is introduced. NTT supports ongoing discussion for the SEBA enhancement, as I mentioned. So it should not be applicable to the FTTH, but also other application. At this moment, when we think about the OLT box, at this moment, white box is dedicated for each PON system. I'm not have the strong objection on this. It should be done. It should be so. But another option would be thinkable. So this is a white box OAN for the multiple service. So this white box can accommodate not only the PON, but also the point-to-point and the xhaul. So the topology-free and service-free concept. I know this is very, very challenging, but I think if we can achieve this, really we need this. So that's why I introduced. Okay, so as a summary, NTT activities are reviewed, and we keep contributing to SEBA. And SEBA should expand its application field, as I mentioned. And as an example, SEBA as xhaul concept are proposed, and we would welcome partners for further discussions, as well as white box OAN issue. So thank you very much for your kind attention.
Do we have any questions for Kota-san?
Thanks, Kota-san. Thanks, Kota-san, for the great presentation. Really interesting, lots of details. I understood that there is already for the xhaul, there is already a demo available.
Yep.
When do you want to donate it to the community, and when can we have a look at it?
Yeah, good question. So,
and last question, when do you plan to go live with it in your network?
Okay. So the first question. So if there's an ONF community supportive for this kind of the xhaul concept, we would like to start the project as soon as possible to expand the SEBA application field. And the second question is no plan for it currently, but sooner or later. So our target is like beyond 5G year, because the preliminary 5G installment should be done by the point-to-point architecture because they are very rushed to the deployment. But eventually, 5G systems are installed in the everywhere. They will face on the large amount of the small cell issues. So in that case, the PON architecture can be accommodated or applicable to such kind of a situation. So we are assuming such time frame. Is that answer for you?
Thanks.
Thank you.